talked about Einstein and about what he considered measuring gravitational waves in his days being impossible for reasons you explained, technology and also knowledge of black holes and neutron stars. But even in the 60s, when you were aware of what was going on, even you considered it crazy. So what changed your mind?
Looking very deeply at the technology, the techniques that Ray Weiss had conceived for doing this, doing detailed analyses of how you would conquer the various forms of noise that such a detector would face, and understanding that although it would be extremely difficult, that there were ways to conquer all of the forms of noise that we could think of.
You must have had an extreme confidence, because in your lecture you discussed the difference in the numbers. I mean, and it is such a tiny number to begin with, and to a layman like myself, it didn't seem like that huge a difference.
Well, to an engineer or a physicist, using light to measure the position of something that is smaller than or about 1/1,000,000th of the wavelength of light, that is extremely difficult. And making measurements of a motion of a mass that are about 1,000,000,000 times smaller than the motion of the Earth that's caused by wind blowing on trees and water droplets falling on the Earth. These tiny motions, but what we're measuring is 1,000,000,000 times smaller. This is very hard to a physicist and an engineer. So we know what can be done easily. We can know what can be done with the best available technology that you can buy. And this was much more difficult than that. So you had to see how could you create new technology that would make it possible.
This was the Ligo System, which is now Advanced Ligo. And basically this is a project which was a culmination of 40, 50 years' work involving hundreds and hundreds of people. And the date, of course, which made history was September 14th, 2015. And the amazing thing about the story is that it was just a few days after LIGO had gone live or online, and it was still being calibrated.
Yeah. Yes, no, that was quite amazing. And it remained the strongest burst of gravitational waves that we had seen. I think it's no longer the strongest, I'm not sure, but it remained the strongest for several years. So it was luck.
This was an event which happened 1.3 billion years ago, and they were, what, two black holes that were spiraling into each other?
Yeah, that's right. The first thing we saw was an event that happened 1.3 billion years ago. We've since then seen events that happened more than 2 billion years ago. But the signals arrived in the last 2 years.
And towards the end of your presentation, you talked about an app which is available, and it seems like there's a similar kind of event happening almost daily.
Almost daily. It's we were saying once per week, but it now looks like it's a little more frequently than once per week. Yes.
And these are other crashes or collisions of black holes, or are there other celestial events?
Collisions of black holes and collisions of neutron stars, and we think, but we're not sure because the signal was rather weak, we have seen a black hole tear a apart a neutron star, but we need a stronger signal of that sort in order to be sure and start extracting the information.
The big takeaway from this, as far as I understand it, is that this gives us completely new tools and a new way of viewing the universe all the way back to the origins. So will it be the case that we'll one day be able to hear the moments after the Big Bang, the creation of the electromagnetic force, for example?
Yes, so these are things that I'm expecting that we will see, we'll hear, not with LIGO, but with other types of gravitational wave detectors. By 20 years from now, I expect, and more as the as this century passes, what we will be observing, what we will be studying, the most interesting things we will be doing is exploring the earliest moments of the universe, the first small fraction of 1 second of the universe's life. What was happening then?
What has it already told us? Because it seems to me, I mean, we're living in a quiet corner of a galaxy and universe, we're told often. It seems like a very violent and very much more active place than anybody realized.
Yeah, so we have seen a lot of violence with radio telescopes, particularly, also with X-ray telescopes. The sky is more violent as seen with those than with optical telescopes. But the particular forms of violence that we are seeing are things that were never seen before. Black holes colliding, although this is the most violent thing we've ever seen except the birth of the universe. There was no electromagnetic waves, no light, no X-rays, no radio waves. The astronomers who work with those kinds of radiation have seen nothing, only gravitational waves. And so we are seeing types of violence that previously unknown, previously unseen.
But at the same time, it's inspirational in a way, because it is kind of yet another unlocked secret.
Yes, no, it's very inspirational, and it gives me additional confidence that over the coming years and decades and centuries, we'll be seeing things that we never dreamed of.
Everybody loves Big Bang Theory. I just started watching it. It kind of passed me by. You were on it as well, so I wanted to ask you about that episode.
It was a lot of fun. I was on it with the 2 other colleagues who have Nobel Prizes, particularly Frances Arnold, a woman who's a friend of mine at Caltech. And we were on set one morning, just for a morning, and we'd been given a copy of this script beforehand. And I had 3 lines, I think, of dialogue, and I got to say no, no, and that was, and Dr. Hafstadter, I presume, and something else I've now forgotten. But the very fact that I had lines meant that the Screen Actors Guild contacted me and said, you should join the Screen Actors Guild, pay $3,000 and become a member of the Screen Actors Guild. I'm not going to pay $3,000 for that, but it was fun anyway.